Well, good evening, who's ever watching this. My name is Chris Girth. I am working here for ECE 445 Senior Design at the University of Illinois Urbana-Champaign. We and my partner Brian Vaughn are group number 1, and we are doing the ski computer. This is our quick little demo video to show you what we built in the event that for whatever reason it doesn't seem to work during our actual demo. So let me go down our project real quickly. It's basically designed to be a speedometer and data logger for activities outside like skiing or skateboarding or snowboarding, where there is no large wheel or acceleration changes to use to measure your velocity. So instead we use a radar-based system. We have 2 large modules in our project. This one right here is called the lower unit. Turn it on real quickly for you. It is designed to contain the radar sensor and a bunch of the analog front-end circuitry that detects your speed and outputs your velocity as a digital frequency that gets wirelessly transmitted up to the upper unit here. This sort of unit was designed to be mounted on the user's arm. See, they're just booted up, and right now it's displaying our speed at 0 miles per hour. If I quickly open up the inside of our lower unit here, you can see clearly on the inside I have our radar sensor here, an amplifier board here, power supply back here, and a digital to analog conversion circuit, as well as a wireless XP transmitter. If I were to simply remember the radar sensors back here, so if I were to close the lid, wave my hand in front of the radar sensor here, you would see that you eventually get the speed start to change there, 2.5 miles per hour or so. And that's just reading the speed of my hand doing this right now. If you actually were to mount this unit on the ground and push it around on a cart, we'll hopefully do that during the demo. You'll actually be able to see the speed change in real time there. The upper unit here contains the wireless receiver right underneath my finger there, as well as buttons that the user can use to access different memory functions. Additionally, underneath here we've got a processor and an accelerometer and a couple other things for gathering data, as well as a double EEPROM where we can store the data permanently. So real quickly, I'm just going to go through here. I'm going to press the record start stop button real quickly here. You see the top light is illuminated now, saying that we're recording a run. So now I can, again, move my hand in front of the speed sensor. You can see that the speed is now changing, and that data is being recorded. I can also just kind of move the upper unit around, and we will track the acceleration changes of the unit. I can also move it really high up in the air and put it back down on the ground and put it back here. Then I'm going to go and press the button to stop recording. And then we quickly go into our menu here. The first menu option shows us that we have one recording that we just made. That was the one we just made right there. And now I'm going to take it over to my computer over here. I'm going to plug it into a USB cable right here that is connected down to my computer, down to the bottom there. Quickly here, we actually have a wireless USB connection on the back of our device like that. And now we're actually connected into the computer. Actually, just for the sake of argument here, let me power cycle this for you. You'll see the device turn off and then back on again, just to show you that we do in fact have the ability to store data and settings over power cycles. There you go, boot it back up again. Now I'm going to go on my computer here, and we have a Python script running that can read data from the device. So I'm going to upload the memory contents from the ski computer. It's on COM port 5, and right now you can see the device has now been rebooted into PC mode, so it's waiting for commands from the computer. Now I'm going to put it in a file called test and hit enter, and now you can see it's downloading pages from the computer. The green light's illuminated, saying that we're getting serial data transmitted back. We're waiting for it to finish downloading. Oh, there we go. So we just finished downloading all of the data we just previously recorded. So now we're going to display one of the runs that we just made. The 3 display run here. There's only one run on the file. That was the one we just made. So I select run number 1, and then it opens up a bunch of windows over here where we can actually see the speed and acceleration. There was the speed for me just moving my hand back and forth in front of it. Here's the acceleration from when I wasn't doing anything at the start of the recording to when I started just moving the unit around. Here's our altitude, which it measures in meters, so the variation wasn't very big. You can see it goes down at the end, though, when we were moving it around. And then additionally, the temperature was stayed steady at 20 degrees Celsius the whole time. So that's the basic gist of our project. Hopefully that gives you guys a brief impression of what we were able to do this semester. And hopefully the actual demo can work so you guys can try it out and see it in person. Thanks again for a great semester, and yeah, thank you again for watching. Bye.